Okay, so we're ready to start getting into making our pad stacks. And what you have um, in front of you here, and I've uploaded this to the Blackboard site, so hopefully you are looking at this, either downloaded it or printed it out or something to look at this data sheet while we're going through this lesson. And this is a data sheet for a particular chip called an LM741 operational amplifier. The reason I picked this one is it's one that we have in the lab. It's also an op amp that we typically use to start with because it's cheap, and you can do a lot of different things with it. Is it really that great a quality? Eh, not really. It doesn't have, it's really probably only used for education and hobbyists at this point. It's not used in industry anymore. I don't think I've ever heard of someone using an LM741 in industry. I could be wrong, but it's one type of chip, as I said, that's very cheap for us to use. Now, there's a lot of other information here, but a data sheet is going to contain information we need for creating footprints and pad stacks. Now, where did I get this data sheet? Well, there's a couple ways you can find this data sheet. One here is that you can just do a Google search for LM741 data sheet, and it will pick up the one that I just have downloaded already, So the difficulty with that, of course, is you need to know the part number that you're looking for in order to look up the data sheet that way. Now, typically what's happened is that you go to an electronics website, and DigiKey is the one that I use and our engineering department uses for the most part. Part of it is that it does have a lot of components available, and the other thing is that we already have it set up as tax exempt for us, which is nice. But you can see here there's what's called semiconductors and there's called passives. And basically there's lots of components. You can do a search here as well, but just to get you an idea here, if I go to integrated circuits, and now there's a lot here, and so you might not how to know where to go here, but you can kind of see some of these things here. Well, let's just look at, for instance, linear amplifiers audio. So this would be if we wanted to make an audio amplifier. And you can see they have a lot of different components here. And these are what are called surface mount components because they'd get mounted on the top of the board. Now, the other ones get mounted on the top of the board, but when I say mounted on the top of the board, the solder connections are on the top side of the board. Now, there are other things we can do when here, like for instance, I can do a search here and apply just to look at through-hole components. We often look at through-hole components to start with just because they're easier for us to solder, especially if you've never soldered before. And okay, we can see an LM386, and it's a Class AB amplifier, which if you know what that means, great. If you don't, it doesn't matter. But for instance, if I was saying, okay, I want to use that part for my design, or that's the part that's being used, I click on it and you can see, hey, I've got a data sheet here. And then if I click on the data sheet, it actually takes me to Texas Instruments website because that's where the component's from. And I have the LM386 low voltage power amplifier. Now, part of the discussion board this week is going to be for you to find a component here, not the one that I found, and upload the data sheet, and then I'm going to have you examine some things about the data sheets and have people respond to it as well. All right, but let's get back to our data sheet that we're going to be looking at, which is the LM741. Now, almost all data sheets are the same, where they might have a typical application at the top, or it might be somewhere lower in the text here. But then they're going to have some like pinout diagrams, and these are the different types of what are called packages that it could come in. And it's going to have then a lot of electrical characteristics. All of this information is important. For instance, what's important here is like the supply voltage. It needs a minimum of plus or minus 10 volts. The nominal, which means that's what it's, would be kind of normally operating at, is plus or minus 15. And then the max is plus or minus 22 or plus or minus 18. And it really depends. Notice there's a 741C or 741A, so it depends on what the actual part number you have. And then there's a bunch of other very useful data that you'll learn as you study. And then this is actually something where they actually have basically what the circuit looks like on the inside. This isn't always given, but if I keep scrolling down, it has, again, an application here. It even has some has some power supply information. It even gives us some layout guidelines, which not all data sheets do that. But one thing you want to notice here for the particular example they were doing is that the components are all located close to the chip, and then there's these two additional capacitors, which we'll talk about more later on. So I keep scrolling down. Oh, finally, I get to the mechanical data, and it's almost always at the bottom of the data sheets. In fact, I say almost always. The reason I use almost always is I hate using the word always, because if there's one case where it's not, then I'm wrong. But I have never seen a data sheet where the CAD drawings aren't at the bottom of the data sheet. So if you find one, hey, you could share it with me, but I wouldn't spend any time investigating it. So this is my data sheet here that we're looking at. Now, this gives me a lot of useful information about the size of the component, gives me information about the pin size as well. And so there's a lot of useful information here. But there's a couple things we need to look at here on the way it's presenting information. First off, notice that the numbers themselves have no units, which is very typical in a CAD diagram, because if you were to put units on all of these numbers, it would get very cluttered. And so somewhere on the diagram, there should be information on what the units are. Now, there are occasions where I have not been able to find the units on a diagram. It just has the numbers, and then you have to kind of say, well, what makes the most sense? Does it make sense that this would be millimeters or inches, or mils, which is another unit we'll talk about here. Well, and in this case, under A, it clearly states that all linear dimensions are in inches, and then parentheses millimeters. So that means what's in parentheses is in millimeters, what's outside is in inches. Now, one thing that I want to put here, and I'm just going to put here, is that there is something that's called a new unit. I'm just typing it in so that you can notice how important this is. And the new unit is mils. One mil is equal to 0.001 inches. So it's 1/1000th of an inch. The reason I point this out is that our dimensions are in inches. So if you have 0.400 inches, this would be equal to 400 mils. Now, that's going to be important because when we're doing some of our diagram creation, a lot of times we'll have it in mils or in millimeters. Now, one thing we should also note here, so I'll just post that here. The other thing we should note here is that there's this 10 comma 16. So let me put a little note there. 10 comma 16 is equal to 10.16 millimeters. And it's millimeters because it's in the parenthesis. Now, the comma is a European thing that in a lot of European nations use the comma as a decimal point. So that's something when you're reading CAD diagrams you want to get used to seeing, is that, and that's also an indication that if you see a number with a comma, that is an indication it's most likely millimeters as opposed to inches. Now, they don't always do the comma. Some diagrams you'll see it still as a decimal point, but when you see that comma, you should not freak out about, well, what's, because you might be thinking, like, I think, like, back mathematics is like, well, is that a point? 10 comma 16, is that XY coordinate? No, the 10 comma 16 is 10.16. All right, Let me post that as well. And so then the other thing I want to point out is notice how there's two numbers here, a top number and a bottom number. So let me put a comment here. So when we have this 0.260, which is equal to 260 mils, and this, and I'll just do this bar here, and this 0.240, which is 240 mils, those are essentially maximum and minimum dimensions. So the maximum width would be 260 mils, the minimum width would be 240 mils. Now, when doing a layout, it really depends on how the particular company wants to do their layouts as far as footprints and everything. Some people would want to say, well, use the maximum because that's the worst case scenario. Other people say, well, use the nominal value, which essentially would be the average of the two. So in this course, I will make it clear which values to be using. In this case, in this course, if there is a range, we're always going to use just the maximum. We're going to do the worst case scenario. So that means there's a range. Now, if you notice one number here where there is no thing, it just says 0.1, which is 100 mils. There is no upper and lower limit. That means we just use the 100 mils or the 0.1. It's only when we have this 2 here where, well, this could be at maximum 0.021, minimum 0.015. So we would use the maximum as the worst case scenario. So that's what we're always going to do in this course. But again, that's not a hard set rule as far as like industry practice goes. Okay, so this is important that we get used to being able to read these CAD diagrams, and sometimes some of the information we're going to need is not directly available on the CAD diagram, meaning that we might have to do some adding and subtracting of different dimensions that are given because of a dimension that we need. And when we get into some more advanced ones, we will talk about that in detail. All right. So next thing here we want to do is talk about pad stacks and how to create them. But we'll end this video for now and go into a new video to create our pad stacks.